Greetings, I'm Squared here, and today we're going to evaluate some functions, and then we're going to use evaluation of functions to create some tables of points. We're not going to graph today, but that's the eventual purpose of doing this, graphing functions. So first of all, you'll see, remember that we talked about function notation. This little g is the name of the function, so this one's name is g, that one's name is f, this one's name is h, so that we know down here which function we're talking about by the g, the h, and the f. Then it tells us what the function rule is. So these are the function rules. And once we know the function rule and we know what value of x we're going to plug into the rule, we can find what that equals, what the function equals at that value. So g of 10 means you're going to go to g of x, this function, you're going to take this rule, and instead of x, because the x has been replaced with 10, you're going to put a 10 there. So we are going to say negative 40, because 4 times 10 is 40, plus 3, and negative 40 plus 3 is negative 37. So we say that g of 10 is negative 37. I'm trying to zoom in a little bit more there. Okay, so now we'll go to number 2, f of 3. So we go to the f function, and f of 3 is the same as x, but x is 3 this time, squared plus 2. So what is 3 squared? It's 9, plus 2 is 11. So f of 3 is 11. And now we go to h. Our function h is 12 over x, but since our x has changed to negative 2, instead of dividing by x, we'll divide by negative 2, and 12 divided by negative 2 is negative 6. h of z, when you see a variable inside this little area, that means you're not going to get a numerical answer. You're going to get an expression. So when we go to h, it says 12 over x, but this tells us to replace the x with the z. So this actually is our answer. We're just going to get an expression like that when there's a variable in it. Now this looks a little different. It has a g of h of 2. And so what we do in that case is we work with the innermost first. First we find out what h of 2 is, and then we come back and plug it in for the number or the x in the g function. So h of 2, that's what I need to find first. So h of 2 means 12 divided by 2. That's 6. Now that I know that this is 6, that means I'm trying to find g of 6. So I go back up to the g function and I replace the x with a 6, and I put a 4 times 6 plus 3. So that's negative 24, because negative 4 times 6 is 24, plus 3, that would get me a negative 21. So g of h of 2 is negative 21. So we'll do the same thing over here. h of 2, we've got to find that first. We already found it, right? We found it over here. That was 6, so we don't really actually need to do it again if we found it over there. So now I have to find f of 6, which is the x squared plus 2. So when I put 6 in there, I get 6 squared. That's 36 plus 2, which gets me 48. So you'll notice that in all those problems, it was a g of some number or variable equals something. There wasn't anything on the right side of the equation, unlike these. So when we get to this, this represents the function. So when we go back up to the top, we find out that that function was negative 4x plus 3. And they're asking us to actually find x when this expression or the rule is 15. So it's kind of backwards. They're not asking you to plug something in. They're saying, hey, what would you have plugged in to get 15? So we solve that equation by undoing it. So we're going to get negative 4x equals 12. And if we divided both sides by negative 4, we get x equals negative 3. Same thing here. h of x was 12 over x. Well, when would that equal negative 3? What would you have to divide 12 by to get a negative 3? Well, you can just think about it. We know that it's probably negative 4, right? But if you didn't know that, you could cross multiply. You could change this to a ratio and then cross multiply. So we'd get negative 3x equals 12, and then we could divide both sides by negative 3. We get x equals negative 4. So that's our little worksheet on evaluation of functions. Now we're going to take that and look at some linear functions and make some tables, again, to eventually graph. So I have a table set up like this so that we can show our work here. I have the function rule in the middle. But basically, this is my x column and this is my y column. Remember, f of x just means y. I'm putting it f of x so that you can get used to that notation. And notice that I'm not given any x's, so I can pick anything I want. A lot of times, if I know that it's linear, and I made these so I know they're linear, I'll just start with -1 and see what happens. So I'll put, remember, now I'm going to find f of -1. I'm plugging it in there, so I get 3 times -1 minus 4. 3 times -1 is -3, minus 4 is -7. So that's my answer there. And then I'll try 0. I like 0 because it usually makes for an easy little arithmetic, because 3 times 0 is 0, and 0 minus 4 is -4. And so I'll just keep going up. I'll do 1, 2. You know, when you're graphing, you don't need to fill in all the spots if you already know what it looks like. It depends on what you're doing. These are all lines, so I usually use a minimum of 3. 4 is better, because sometimes you can be off on 1. So we're going to find f of 1. So 3 times 1 minus 4 is -1, and f of 2, 3 times 2 is 6, minus 4 is 2. And you can do more if you want, but eventually we're going to graph those. But for today, we're just making tables. So let's look over here. We can start with -2 this time. It doesn't really matter what you start with. You don't want to be crazy with it, because if you have to eventually end up graphing it, you don't want your graph paper to have to be really huge or count by 5s or something. So you can do f of -2 like that, and you'd get -2 plus 7 equals 5. Or you can just say, oh, -1 plus 7 is 6. If you don't need to show work because you can do it in your head, like 0 plus 7, if you don't want to write that down, this is just to show work. It's not necessary. It's just that sometimes when they're complicated, it's better to have a little work. So 1 plus 7 is 8. And that's all we'll do on that one. So this one, we are subtracting an x. So let's just do -2, -1, 0, 1. -2. F of -2 means 6 minus 2 times -2. Well, -2 times a -2, or subtracting a -4, either way you want to look at it, 6 plus 4 is going to be 10. And 6 plus 2 is going to be 8. And 6 minus 0 is going to be 6. And 6 minus 2 is going to be 4. So I was just plugging them in kind of in my head. And you can do that, or you can show the work, either way. Now this is a little bit trickier. The next two are fractions. I kind of like to look at it and think about how it would be easier. So for example, if I put a 1 in there and I find f of 1, I get 1/2 times 1 plus 5. Well, 1/2 times 1 is 1/2. 5 plus 1/2 is 5.5. And it's easier to graph it usually with the decimals. But if I don't want decimals and I'm graphing, I don't have to do 1, 2, 3, 4. I can realize, oh, what number can I take half of without a decimal? Oh, even numbers. Okay, so I'll just use even numbers. So I'll put 0 in and I'll get a 5. I'll get 1/2 of 2, I know is 1, so 1 plus 5 is 6. 1/2 of 4 is 2, and plus 5 is 7. And so it avoids the decimals if you care. Some people don't care. Maybe you're using calculator and you don't care if there's a decimal. But if you want to, you can avoid it like that. For example, on this one, it has divided by 3. So I'll say, hey, why don't I just use multiples of 3? Why don't I just use those numbers? Because when I do, I won't get the decimal. So if I put a -3 over 3, that's a -1. So 1 minus a -1 is the same as 1 plus 1, and that gets me a 2. Or if I say 1 minus 0 over 3, that's 1 minus 0. What's 1 minus 0? 1. And then I can say 1 minus 3 over 3, that's a 1. So 1 minus 1 is 0. And I could say 1 minus 6 over 3, and that's 1 minus 2, which is a -1. Now, it doesn't mean you can't use a 1, something that's not a multiple of 3. You could do that, but then you just get 2/3 or 0.6 repeating, and you might not like to graph it like that. So it's always good to look at the equation first and kind of get an idea of what might give you decimals and what might not if there's a fraction. Okay, so we evaluated expressions, we made tables, and the next step is going to be graphing. So good luck with that. M squared, signing out.